So we've done the easy part. We found s squared and we found n minus 1, no trouble. That leads to the chi-squares. All right, so we can go find them in here. And I'm going to kind of use the same format that I used before. Matter of fact, it's the same book I used before, but bear with me. Okay, so our confidence level for this, they want a 95%. So let me go back here and change this from 0.9 to 0.95. Oops, 0.95. There we go. I'm with it. All right, so already we're in good shape, but n is equal to the number, the count in values from here to here. I know it's 10, but I just love using the formula for if I could use it. And there we go. So it's 2.7 and 19.02. Now remember, I found these with the chi-sq.inv with 0.025 and degrees of freedom 9, and then chi-sq.inv.rt for the other one. Or you can use chi-inverse for both of them. You'll just have to use the 0.025 in one of them and the 0.975 in the other one. Personally, I prefer the new functions. I think they make more sense, but whatever. Okay, so you get those two numbers, 2.7 and 19.023. So which one's which? Well, the smaller one is over here, actually. What was it, 2.7? Not that you can answer me. I don't know why I ask. 2.700. And this one was 19.023, I think it was. Oops. Come back. There it is, 19.023. While I'm on the subject, I can close that. All right. Cool. And then the question becomes, okay, well, what are those numbers? Can't we make Excel find those numbers for us? Why, sure you can. So let's do it. We need a lower bound and we need an upper bound. Okay. So let's see what we have here. Oh, hey, I hate that new feature. I know everybody loves it in Windows, but I hate it. I hate trying to fuss with my Windows and have it go all the way to the huge boundaries of the screen, and I didn't want that. Anyway, not that you care, but you know, n minus 1, which is degrees of freedom, times the variance, which we already found, it's over here in this cell, and we want to divide it by that 19.023. And then I'm going to do it again. N minus 1 times 11118 or whatever divided by, now I'm going to divide it by the 2.7. There we go. So our numbers are 5260.5, 5260.54, comma, my decimal point keeps not working. And then the other one is 37057.7. And there we go. You now have the formula for the variance, or the confidence interval for the variance. What about the standard deviation? Well, remember the standard deviation, I should have said this is for variance. There we go. Okay, now to find the standard deviation, we're going to do the same thing, but what we'll do is we'll just take the square root of what we just did. So same formulas, and you could just retype it if you wanted, but I mean, why bother? I say let's not worry about it, right? And all we need to do is equal SQRT of that number. Enter, and then I can even drag it. And there's the other one. So 72.53. Here, hold on, let me pause this. There we go. 72.53, 192.5. We take the square roots of both of the numbers we found for variance, and lo and behold, you have the one for standard deviation, and it's all done. Easy as pie. All right, now with that, they want us to interpret. Well, we are 95% sure, or confident, that the true standard deviation for verbal GRE scores is between 72.53 and 192.50. There we go. All right, I'll have to talk about this next time at the very beginning of my 9.5 video, and then that'll be it, and we'll be done with chapter 9. See you then.